Alright guys, so moving on to the next batch of questions. What we have for our first one has to do with the clocks and why certain clocks run, how you say, slow. So let's dive in. The statement reads, synchronized clocks are stationed at regular intervals 1,000,000 kilometers apart along a straight line. When the clock next to you reads 12 noon, A, what do you see on the 90th clock down the line? And B, what time do you observe on that clock? Okay, so the question is, what do we think we're going to see and what is actually on the clock? Okay, so solution for A is that light from the 90th clock took, well, it's going to take time for the signal to travel to us. It can only travel at the speed of light. It's not instantaneous, although we might think it is. So how do we find the distance it traveled? Well, we were told we had 90 clocks spaced out by 1,000,000 kilometers. A kilometer is 10 to the 3. A million is 10 to the 6. So 10 to the 6 times 10 to the 3 gives us 6 plus 3, which is 9, hence the 10 to the 9 meters. And 90 comes from the 90th clock. The speed of light is 3.0 times 10 to the 8th meters per second. So we have d over v, which gives us time. And with that, we end up with 300 seconds or 5 minutes to reach me. So the light took 5 minutes to reach me. So the time I see on the clock read from 5 minutes before that when our clock was 12. Okay, so 12 minus 5 minutes gives us 11:55 a.m. What is observed, however, is that the time on the clock when ours is 12, theirs is also 12, we just don't see it yet. So we got to take into account that the light has to come to us from somewhere. So with that, that concludes that, and we'll see another example where we talk about this in more depth soon.